Hi, welcome to another video on the KME channel. In today's episode I will tell you about E10 fuel. This is a new fuel that we can able to fill up at gas stations in Poland for several weeks. You ask, can you refuel this fuel from your cars? Does it have any bad effects? Can it exert on your vehicles? I have encountered many inquiries from you about this fuel, so I decided to run some tests using our company car, a Ford Fiesta with a 1.0 EcoBoost engine as an example. But before we get to those tests, I'll tell you my thoughts, what they are about this fuel. E10 fuel is nothing more than ordinary 98 fuel, which contains a maximum of 10% of biocomponents per liter of fuel. In this case, it is alcohol. Is it any better than regular fuel? No, it is not, because this 10% is not as caloric as fuel 98. It is something that will burn, but it will not give us exactly the same energy as pure fuel 98. In this case, therefore, the car will underperform by a few percent, which means that it will also burn slightly more for the same distance traveled on this fuel. In addition, it entails many other negative effects. As you know, alcohol absorbs moisture, and here we have an insignificant concentration, as it is 10%, but it is always something. In cars that are used less frequently, sporadically, this moisture will accumulate in the tank, in the fuel lines, in aged cars, in carburetors, in accumulators, cageatronics, which can cause corrosion of these components, and after a long time the inefficiency or even failure manifested by the fact that the car will lose power or there will be a problem with starting it. Here I have introduced you to several such devices. Here we have a carburetor, a Weber in this case. This is a component that does not like moisture. There are a lot of very precise, accurate mechanical components that, if they corrode, will stop working as they should. The same is the electric fuel pump submerged in the tank. If its bore corrodes, the electric motor in this pump will be overloaded, there will be seizures, weaker output, lower pressure, consequently its seizure and inability to start the car. The next element we have is the injection bar with injectors. And here too, if there is moisture in this fuel, if there is this water all the time, it will rotate in this circuit and the car will be used less frequently than, say, every day, once a week, once a couple of times a month. There may also be a failure because these injectors will initially lose their output. At a certain stage, there may be a problem with starting on a cold engine. As a consequence of prolonged use, there will be a problem starting this car completely. The same was true a few years ago, when biocomponents in diesel fuel appeared on the market. I have been in the business of repairing and servicing diesel engines and injection systems for many, many years, and when fuels with biocomponents appeared at the stations, there were more orders for fuel system repairs in my business. And here, as if analogous to what I'm saying, the moisture in this fuel caused seizures, corrosion of injectors, injection pumps, high pressure pumps, pump injectors, and this in various cars. At first, just such a first symptom was cars that were used less frequently, that is, such construction machinery, agricultural machinery, where, let's say, through the winter they are seasoned, rarely used. And here in agriculture, taking advantage of subsidies of perhaps 1 hectare of land, it is an obligation to purchase fuel with biocomponents. And hence to this day, before at least the harvest season, many farmers bring us fuel pumps from harvesters, from tractors of the kind they use in the summer, with the symptom that they cannot start these machines. This is caused by the fact that the moisture from this fuel settles on the precise parts of these components. This corrodes over time, that is weeks, months. This corrosion intensifies, and when someone wants to start a particular machine or engine, they have a problem. Then, when it is needed most, he finds out that he can't use it. And here, by analogy, Taking E10 fuel, for example, I think it will be similar. In cars that are used frequently, this problem may not be so obvious right away, but in cars that are used infrequently and we refuel them with E10 fuel, this problem will progress. This will not manifest itself, of course, from week to week, month to month. It will take 6 months, a year for this to happen. But this wear and tear on fuel components will certainly be faster. This erosion inside them will progress faster than on regular E10 fuel. As for the performance of the car, they won't be better at all either, because that 10% of alcohol that's in the fuel, it doesn't have the energy if the fuel itself, 98 or 95. You will say that sports fuels, some are built on alcohol. Yes, but that's not the concentration, because sports fuels, in order to get more power output of the engine, its performance, this concentration must be higher than 30%. In addition, then the fuel system gets very serviceable. This car needs to be skillfully serviced. After using it on sports fuel, you have to pump this fuel out, you have to pour normal fuel, you have to clean these components, so it is very serviceable. This is handled by professional services, professional mechanics who know how to handle it. But it's difficult for you, as normal car users, to pump out this fuel and pour yourself fuel without biocomponents after every drive, returning to the garage. This is very difficult, in such garage conditions even unfeasible and dangerous, because this fuel, which evaporates or spills somewhere, can cause irritation of at least the skin, and in the worst case even a car and building fire. So I do not recommend such operations. As for other things, when it comes to the combustion of this fuel in the car, comparing the equal distance traveled by the car on E10 fuel and on 98 fuel, based on my own experience with our company car, I came to the conclusion that the car powered by E10 fuel burns a few percent more than that powered by 98 fuel. This is caused precisely by the fact that there is less energy in this fuel. In order to drive the car at a similar speed, you have to push the gas minimally more, and this burns more of this fuel. The same analogy applies to sports engines fueled by fuel with alcohol. In addition to the fact that it has anti-knock properties, we can accelerate the ignition, but we have to supply the engine at the same time with a larger amount of this fuel than if we drove on regular fuel, or 100 octane available at Shell. So here it is not so clear that we get more engine power on the same amount of fuel. When driving, tuning a car on E85 fuel, and I've had the pleasure of tuning several drift cars, we have to supply the engine with about 30-35% more fuel than if we tuned them on normal fuel. So here, at a concentration of 10%, not only do we not get anything because this engine will not automatically accelerate the ignition for us, it will not automatically add more fuel, but this concentration is too small. To get anything from the parameters of our car, we would have to have this concentration of at least 30%, and to make it satisfactory and noticeable, it would have to be 60-80%. But this in turn results in our fuel system and car becoming very serviceable. What such an ordinary user, using the car on a daily basis for commuting, or provided some service with it, cannot afford. He simply has to get into this car, start it, and leave when needed. In sports, when this car is handled by several people, it is as feasible as possible, but it is, as I said, very expensive and labor-intensive. What am I getting at? I'd like to sum it up by saying that there are a lot more of these negative effects in this fuel than the benefits of using it. Of course, the modern world, the present world, is sort of surrounded by such an eco-envelope. It has to be biocomponent because it's greener. Someone counted it, someone came up with it that way. However, this alcohol that is added to the fuel, it is made from plants, admittedly. Maybe from grain or from beets, maybe in some other way as well, but it is generally of plant origin. And this, of course, can be bio. However, to produce this grain, that is to sow, harvest, process, for this too, a mass of energy is required. To sow a field, you first need to plow, cultivate, and this will probably be done by a diesel tractor burning through normal diesel fuel. Later, to make that grain grow, you have to use fertilizers, which also sort of come from various chemical processes. Later, to harvest that grain, you have to run a combine, which is also powered by a diesel engine and burns up a mass of black fuel. The next step is to deliver this grain or other plants in another form to some factory or some company that processes a ton of alcohol, and for this too, a lot of energy is needed from an engine, probably a diesel one, since it will be either a large tractor with trailers or a truck that will haul it. At the very end, with the process already distilled, a lot of heat energy is also needed, and this will come either from gas coal or simply electricity, which in Poland is largely generated from coal. Also, I don't know on what scale this oscillates, but if we counted this carbon footprint, I think that this 10% content of this alcohol in the fuel is not at all as green as it may seem. This fuel is not at all 10% greener with these biocomponents than it is in this crude form re-refined from crude oil. This is such one comment. The second remark will be that, as you have already noticed yourselves, this fuel, which includes biocomponents, is not at all cheaper than regular fuel. It is a few pennies more expensive than the fuel that used to be 95, which may also indicate that these biocomponents are not so eco and so cheap at all. At the same time that Poland added up to 10% alcohol to fuel, Sweden lowered the threshold from 10 to a maximum of 6%. So they have already noticed that it is economically unjustifiable to produce these biocomponents. Moreover, they probably counted that this carbon footprint and the share of these harmful substances is greater than it would translate into this environmental performance. Of course, this is heavily lobbied for these days. We are heavily educated that everything must be eco. However, as you have noticed, in this Europe, the whole world will not be saved. And I think this is where you need to use common sense. What am I getting at? Analyzing, as I said earlier, referring to diesel fuel, now to e-fuel. The only fuel that does not contain biocomponents is LPG fuel, which I also have a lot of contact with. It is, in my opinion, the most environmentally friendly fuel for these times, the most economical. Also here it will hurt your wallets the least. You will be able to drive almost twice as many kilometers for the same amount. The gas installation that you put in your car will pay for itself after a few months, even without driving hundreds of thousands a year. LPG fuel is a derivative of oil refining, so you could say that it is produced in the most environmentally friendly way possible. It is a waste product that is reused, burned. From the combustion of this fuel, the least harmful substances are produced, and an additional advantage is that its price is low enough that we can afford to drive twice as many kilometers than on ordinary fuel. I sincerely thank you for your attention. I hope my story about the new fuel will be helpful to you. See you in the next episode of On Gas. Hi.